Okay, so for my exploration, I did the Discovery Park, the South Bluff. This is in Seattle. It's in like the Queen Anne area, and I was examining it for like landslides. So first, the Seattle area is characterized by glaciers. There has been at least 5 major advances of glaciers in the Seattle area, the most recent glacier being the Puget Lobe of the Cordilleran ice sheet. This ice sheet was one of 2 huge ice sheets that covered North America. So one you can see on the left side of the screen here, you have the Cordilleran ice sheet, and then on the right side, or sort of in the middle of the screen, you have the Laurentide ice sheet. These were the 2 major ice sheets at the time. More specifically, we have the Puget Lobe that I mentioned. This was part of the ice sheet that came down into the Puget Sound area. So you can see Seattle is over here. It was covered. Tacoma was covered. Everett, sort of until like I think about the mountains are over here somewhere. Yeah, the Cascade Range is right here. So it kind of went up until the base of those mountains. So moving on to how glaciers work. Glacier movements are characterized by advancing and retreating. It is during this advancing and retreating where sediments get deposited, as when the ice melts, it releases some of the sediments it once had and leaves it behind in the landscape. So here you can see in this diagram, the glacier is first advancing and it picks up a boulder and it continues to advance and it transports it, and then eventually when the glacier retreats, it leaves that boulder in the landscape, in its new landscape essentially. So here this is important to in terms of context, because in Discovery Park this area is characterized by glaciers, of course, because it's in the Seattle area, but also the sort of transporting of sediments and things like that to the area. So this is a landslide area, part of one of the areas that had a landslide. As you can see, like these like miscellaneous tree roots hanging off, and sort of how the landscape looks. There was clearly a landslide here in the past. So first we have to get into sort of why these landslides happen, and it's because of the layers of sort of Washington's layers that have been characterized by glaciers. So the first layer is the Olympia beds, which are brownish layered rocks at the bottom of the bluff. These rocks were deposited during what is known as an interglacial period, which is the period of time between ice ages before the next glacier comes. The environment at the time of the deposit of the Olympia beds would have been similar to today, though with less urbanization and different types of wildlife. The second layer on top of the Olympia beds is Lawton clay, which is fine layers of dark and gray clay and light silt that is around 82 to 100 feet thick. These layers were deposited during the last ice age when the Puget Lobe created a dam that resulted in lakes being formed. The Lawton clay, which is the fine gray sediment that rivers and streams transported into the lake and piled up because of the dam. After the Puget Lobe retreated, the dam melted and it left the Lawton clay bed layers. So the third layer is the Esperance sand, which was created when the Puget Lobe displaced streams, causing them to deposit sand and silt and gravel up to 200 feet thick through advanced outwash. The last layer is the surface layer known as Vashon Till, or locally known as hardpan. It is made up of silt, sand, cobbles, pebbles, and boulders, and it can be 30 feet thick. This layer is created once the ice arrives through the advancement and deposits of other sediments that has collected in the new area. So this diagram sort of represents that. You can see the Esperance sand, the Lawton clay, the Olympia beds, sort of different terminology, but they all mean sort of the same thing. So this is just another diagram. This is more detailed, but another way you can see sort of the layers of the sand. And so when I actually went to visit the site, this was sort of, this was below the original surface. There was like sort of a little landslide that happened. You could kind of go off the trail and go down to where that little landslide had happened, as it was now stable, and it was just characterized by sand. It was like all sand. It was honestly like being on a beach. It was kind of cool. So essentially, why are landslides common here? So landslides are common at the Discovery Park South Bluff location, and sort of Discovery Park in itself, the Seattle area, because of the difference in Lawton clay and the Esperance sand. Because the Esperance sand is a porous layer that allows water to flow through it easily. It's when it's on a slippery surface like the Lawton clay, it does not allow water to flow through it easily, so it results in a weakening in the layers and the friction with the layers, and it makes it susceptible to sliding. So essentially we have this like hard rock here in the blue, and that doesn't absorb any water, so the water just sits on top underneath this brown layer, and then that creates the sand to move, which is what happens in Discovery Park. So here, these are real images of the Discovery Park landslides. This is not this exact location of the South Bluff, but it is the south side. You can see these tree roots hanging off here, as there was obviously like once land, but it had all slipped down due to like, see, these are like the sand layers that had slipped down below, off the layers below it, and yeah, created a landslide. This is another image of a little, this is a lot smaller of a landslide. But yeah, so that's sort of like the data. There is no like hardcore data of what's happened just because it's a park and it doesn't really affect anybody. So it's not necessary that they really record the data or anything like that on the landslides that do happen or have happened in the past. This was another like little small landslide area. You can see the sand like slid down at one point and now it's just kind of this little reserve area, but this is all sand right here. So the Esperance sand. And this is sort of Discovery Park, a map of it. I was looking at this location over here with boxes and yeah, so in terms of mitigation, there's not much that needs to be done because the park it's essentially already mitigated because it is a park. There are some houses, but the houses are located like over here, like away from the bluffs. And so thus if any like landslides happen, it doesn't really affect any people in the area. It mostly just affects like the wildlife surrounding it. It might close the beach because you can go down to the beach down here, but other than that, there really is no mitigation that needs to happen just because it's already mitigated through it being a park.